Ever stop and wonder how your phone actually gets it when you say, "Hey, what's the weather?" Or, how a search engine digs through literally billions of pages to find that one article you're looking for? Well, today we're going to pull back the curtain on how we teach computers to understand our language. It's a field with some seriously powerful tools, and we are going to dive right in.
I mean, just think about it for a second. The internet is this massive, ever-growing ocean of text, right? We're talking articles, social media posts, emails, everything. And to a computer, it's all just a jumble of unstructured noise. So how in the world does it pinpoint what you need, or how does a chatbot understand what you're even asking?
And that's exactly where natural language processing, or NLP for short, comes into play. It's the branch of AI that's all about bridging that gap. NLP is about building systems that don't just see a sequence of letters, but can actually understand that the word apple might be a company, or a fruit, or maybe even a person's name, all depending on the context.
So here's our game plan. First up, we're going to tackle a simple method called an n-gram, and you'll see pretty quickly why language is so tricky for computers. Then we'll meet our hero for the day, a super powerful library called spaCy. We'll even peek under the hood to see how it thinks. And then we'll wrap up by getting you hands-on with your very first lines of code.
Okay, so let's start with a really foundational concept. To really get why modern NLP tools are such a big deal, we've got to see just how messy raw text can be. And we're going to explore this through a pretty simple idea called the n-gram.
So what is an n-gram? It's actually a really simple idea. It's just a sequence of n items from a piece of text. In our case, n words. So a 2-gram is just a pair of words that are next to each other. A 3-gram is a group of 3, and you get the idea. The hope is that by looking at these common little sequences, we can start to find meaningful phrases and patterns.
And in a perfect world, if we're analyzing a text about, say, the Python language, our program would find these nice, clean pairs, like high level and programming. See, that's a meaningful phrase. It tells us something important about the topic. This is exactly the kind of stuff we're looking for.
But here comes the reality check. Raw text is almost never clean. You're way more likely to get total junk like this n-gram here. Just look at all those weird new line characters, the little n's. This pair is completely meaningless because our simple little program has no idea how to handle formatting or context.
And this really gets to the heart of the problem, right? Raw text is just full of these traps. Hidden formatting like new lines, stray punctuation marks, weird characters, citations. A basic n-gram approach might even grab the last word of one sentence and pair it with the first word of the next, creating complete and utter nonsense.
So the crucial point here is this. You can't just throw raw text at an algorithm and expect good results. It's just not going to happen. You need an intelligent, multi-step process to clean and prep the data first. You got to strip out the junk, handle the punctuation, recognize where sentences begin and end. This pre-processing step is absolutely vital.
Now you might be thinking, do I really have to write custom code to handle all that cleaning for every single project? That sounds like a total nightmare. Well, thankfully, we don't have to reinvent the wheel. It is time to introduce spaCy, an incredible library that is designed to handle all of this complexity for us.
spaCy actually calls itself industrial-strength natural language processing. And honestly, that's not an exaggeration. This isn't just some tool for academic experiments. No, this is a fast, efficient, open-source Python library that's built for real-world products that have to process massive amounts of text.
And spaCy is an absolute powerhouse. I mean, right out of the box, it does a whole suite of things. It intelligently splits text into words and punctuation. That's a process called tokenization. Then it tags each word with its part of speech, identifying nouns, verbs, adjectives. It can even find and label real-world things, like people's names or companies. And on top of all that, it can even calculate how similar two words are in meaning. It's basically a complete toolkit for analyzing text.
Okay, so we know what it does, but how does it actually do it? To really use spaCy well, it really helps to understand its core design, kind of the way it thinks about language. So let's take a quick look under the hood.
So the big idea in spaCy is something called the processing pipeline. The best way to think about it is like a factory assembly line. You feed your raw, messy text in at one end, and it passes through a series of different stations, a tokenizer, a tagger, a parser, and a few others. And what comes out at the very end is this highly structured and really intelligent doc object.
So let's trace that data flow. Everything starts with what's called the language object, which by convention we call NLP.
When you give it some text, the very first stop on the assembly line is the tokenizer. This is the part that solves our whole n-gram problem. It intelligently handles all the punctuations, spacing, and weird characters to create a nice clean sequence of tokens. These tokens then form the foundation of that central doc object, which gets passed down the line to be enriched with all sorts of other linguistic info.
So that doc object, that's really the heart of spaCy. Don't think of it as just your text. Think of it as a supercharged container. It holds every single word, every punctuation mark, and all the rich linguistic analysis that the pipeline generated. It's the final intelligent version of your document.
And inside that doc are these individual token objects. Now, a token isn't just a string of letters. It's a word that has context. It knows it's part of speech, it knows its grammatical role in the sentence, it knows if it's part of a person's name, and so much more. It is a truly smart representation of a word.
And if you want to look at a phrase with multiple words, like our high-level programming example from before, you use a span. A span is basically just a slice of the doc. It gives you an efficient way to look at a sequence of tokens without having to copy a bunch of data around.
And here's the secret sauce. This is the aha moment that makes spaCy so fast and efficient. Instead of storing the full text of every single word multiple times, which would just eat up your computer's memory, it stores each unique word only once. The doc object then just works with a compact array of unique IDs. It's this super clever design that lets spaCy process millions of documents without making your computer crash.
All right, enough theory. The absolute best way to understand spaCy is to actually use it. So let's walk through the exact steps you take to get this running, and you're going to see just how incredibly simple it is to get started.
Okay, before you write a single line of code, you need one of spaCy's trained pipelines. You can think of these as containing the statistical models, like the brain, that allows spaCy to make all its smart predictions about language. This simple command here downloads the small English model, which is absolutely perfect for getting started.
And this is where the magic happens. Look at this! In just 3 lines of code, we solve that whole messy text problem we were talking about. You import spaCy, you load the model you just downloaded, and then you pass your text to the NLP object. That's it! That doc variable now holds that powerful, fully analyzed object, and it's all ready to go.
And once you have your doc object, playing around with it is super intuitive. So for a sentence like, "Give it back," he pleaded, we can create a span for the phrase "it back" just by slicing the doc. And from there, we can analyze that specific phrase, we can look at its individual tokens, and explore its whole grammatical structure. It's really that easy.
So there you have it. In just a few minutes, we've gone all the way from the messy reality of raw text to this powerful, structured processing pipeline. You now have the fundamental building blocks to analyze text at a massive scale. So the only real question left is, what problems are you going to solve? What are you going to build with it?